students. In this video, we will be doing more practice questions on exponents and how to graph them. And I will introduce more concepts and formulas. Okay, so in question 2, it's asking to solve the following exponential equations. Okay, so remember here you're trying to solve an exponential equation. Okay, so at the end you will be finding a numerical value for your variable, which could be x, y, or whatever. But the type of equation you're solving here is exponential. Previously, you were solving linear, quadratic, or rational equations, but now let's do a few of the exponential equation. It's basically the same thing, but there is one extra step. Okay, I'll show you how. So the first one, 3 to the power 2x plus 3 equals 3 to the power 5. So remember what we told so far about the exponents. In the exponents, you have a base and you have an exponent. So you have a base and an exponent, right? Or a power. When you want to have both sides to be equal, both of the bases must be equal. So base 1 must be equal to base 2. And then let me call it like circle or whatever, the power 1 or exponent 1 must be equal to power 2. If these two things happen simultaneously, then you could say that this side of the equation or right side of the equation is equal to the left side of the equation. So here in this case we have 3 to the power 2x plus 3 equals 3 to the power 5. We have an exponential equation. As you can see, the base is 3. So if the bases are both 3 and equal, which it's the same number, then the exponent or the powers on both sides must be equal. If these two conditions are met, then we could say that right side is equal to the left side. So here, what we should do, we should say that 2x plus 3 must be equal to 5, right? Because 2x plus 3 is actually the exponent on this side, right? And 5 is the exponent on the other side. Okay, so not only the two bases must be equal, but also the two exponents must be equal. That's how I get this equation. And this is a very simple type of linear equation. So you would say 2x is equal to 5 minus 3, which is 2. So x would be 2 divided by 2, which is 1. And this is the final answer. So you solve an exponential equation, the x is 1. Let's test the answer. So the original question here was 3 to the power 2x plus 3 must be equal to 3 to the power 5. Let's plug in the 1 and see if it works out. So 2 times 1 is 2 plus 3 is 5. And you can see on the other side, we have exactly the same thing. So x equal to 1 is the correct answer. Now let's move on to the next question. So we did question 2 part A, now part B. In part B, we have 5 to the power 5x minus 1 equals to 125 to the power 4x. So here, remember, back to what I just said like a few minutes ago, not only the two bases must be equal, but also the exponent or powers should be equal. But in this equation, let me write it down. So 5 to the power 5x minus 1 must be, and then 125 to the power 4x. So here, as you can see, not only the two bases are different, but also the two exponents are different. And this is rather tricky, but let's go back and recheck the conditions. We have to change the bases, okay, so they would be equal to one another. Then in the next step, we have to make sure the powers are equal. Remember the question that we did at the end of the previous video, converting the base from one to another? That's what we will be doing here. So 125, I want to change it. I want to take the common base as 5. So I divide it by 5, I will get 25. 25 divided by 5, I would get another 5. 5 again divided by another 5, it's 1. So 125 is equal to 5 to the power 3. So now let's see what we can do here. So I have 5 to the power 5x minus 1 equals, instead of 125, I write 5 to the power 3, and then there is 4 to the power x here. So it will turn into 5 to the power 12x. Okay. So now here you can see that the two bases are both 5. You converted 125 to 5 to the power something. So the two bases are the same. That's the good thing. Perfect. Base 1 is equal to base 2. Now you have to make sure power 1 is equal to the power 2, or exponent 1 is equal to exponent 2. That's the next step. So I will write it down. So 5x minus 1 must be equal to 12x. This is a simple linear equation, right? So it will turn into 5x minus 12x equals to 1 minus 7x is equal to 1. And from here, your x would be 1 over 7, negative 1 over 7. You can see here that the x is not only a fraction, but also a negative value, which is perfectly okay. Now, let's test the answer. So here, instead of x, I just substituted negative 1 over 7. So 5 times negative 1 over 7 minus 1 must be equal to 125. 4 times negative 1 over 7. Now let's simplify. So here that would be negative 5 over 7 minus 1. And here that would be 125 negative 4 over 7. Again, here if I just simplify it, it would be negative 12 over 7. And here I would have 125. It's 5 to the power 3. So it will be negative 4 over 7, which would be 5 minus 12 over 7. And you can see that the two sides are perfectly equal, and which means that you have the correct answer. So the second one is done. Let's move on to the third one. So we have 7 to the power 5x equal 343 to the power 3x plus 2. Again, we have to make sure that the bases are the same. We have to convert one of the bases to the other. It's always easier to change from the bigger one to the smaller one. And usually the two bases would be, convertible. So 343 divided by 7, it will be 49. 49 divided by 7, it's 7. 7 divided by 7, it's 1. So 343, it's 7 to the power 3. Okay, so I'll just rewrite the equation and try to solve it. Okay, so here we have 7 to the power 5x, 7 to the power 5x equal, so instead of 343, I write 7 to the power 3 raised to the power, and then 3x plus 2. Okay, 3x plus 2, which it's perfect because here I can simplify it. It's 7 to the power 9x plus 6, right? The bases are the same. Then 5x must be equal to 9x plus 6. So I would have 5x minus 9x equal to 6, negative 4x equal to 6. X would be negative 3 over 2. Perfect. Now, in order to just save some time, I wouldn't check the answer, but I want you all, after each equation, go back, plug it in, and make sure that's the correct answer. So we did C. Now let's do D. D, it's a little bit different from the previous ones because here you have a coefficient, which is 2, and then an exponent. And here on this side, you have a constant, but all of them are convertible to the base 2. So let's do it together. Okay, so I'm going to write it here. 2 to the power x multiplied by 2, it's equal to, on this side, I have 64 square root of 2. So on this side, let's start by simplifying. The base is the same, so I'm going to use the rules of exponent. This will turn into 2 to the power x plus 1. This side, definitely for sure, I have to make sure that the bases are 2. So 64, it's 2 to the power 6, and square root of 2 is 2 to the power 1/2, right? So again, the bases are the same. If I add these two, it would be 6.5, right? Now again, I end up with an equation which the bases are the same. Okay, can you see here? The bases are the same. So that means the exponent must be the same. So x plus 1, it's 6.5. In other words, if we solve this linear equation, the x must be equal to 5.5. Okay, we solved number D. Please do check your answer, test it, make sure it's the correct answer. Now I'm going to do the next one. So it's 9 divided by 49. The base is a fraction to the power negative x. On the other side, I also have a different base, but if you look at closely, the bases are somehow related. So let's put it this way. 9 divided by 49, we can rewrite it as 3 over 7, both of them to the power 2, which is 3 over 7 to the power 2, right? But what I can do, I can flip it, right? Flip the base, make it 7 over 3, and then make the exponent as negative. By doing so, this side, the base, is converted to exactly the same base as the other side, and it helps me to solve my equation. So here, what I will do, I will just write 7 to the power 3 instead of 9 over 49. I just rewrite it as this, and then negative x here on the outside. Then I have 7 over 3, and I have 2x minus 2. The bases are exactly the same. The last step is to make sure that the exponents are the same. So here, negative 2 times negative x is 2x is equal to 2x minus 2. Okay, so 2x minus 2x is equal to negative 2. So 0 is equal to negative 2, which is not possible. Okay, not possible. So we ended up with this answer, which means that there is no x value which makes this equation satisfied. So this equation has got no answer. Let's continue with part F. Again, in part F, bases are not the same, but remember 128 is 64 times 2, which is 2 to the power 7. I use this fact and make sure that all the bases are the same. So let's rewrite everything. So 2 to the power, okay, 2 to the power 3x minus 1 on this side. On this side, I just 128 is replaced by 2 to the power 7, and then 3x on the outside, and then I have another 2 to the power 3x here. The good thing is here, I have all the bases the same. So what I'll do, I just make sure that the exponents are also the same. So I will end up, after simplification, I will end up with 7, it's 21x plus 3x. Okay, right? 21. So 3x minus 1 would be equal to 24x. By solving this one, I would have 3x minus 24x is equal to 1. Negative 21x is equal to 1. X is minus 1 over 21. Your final answer, the final value, would be negative 1 over 21. Okay, so if you take a look at the handout, I did all the question up to part F. The next one is your homework. I want you to solve part G to J and submit it under D12. Then in the next video, I will talk about exponential functions and then the basic characteristics of the graphs of the exponential function. What I mean is the domain, range, x intersection, y intersect, and asymptotes. I'll see you soon in the next video.